We'll open up the discussion. You can ask either Mark or Carrie any questions that you have about their PRISM investigations. We do have one online, but it's for Carrie, so I'll wait till she gets up here.
So I see one in the chat. Should I answer that?
Yeah, sure. I'll read it real quick. There's one from the chat from Mark. It says, do you have an idea where you would land in that region?
So we have not selected the landing site. We were going to work with the PRISM and CLIPS to select a landing site.
Okay, this is for Mark too. This is Amanda Hendricks. Let's see, I was wondering if you could just say a little bit more about what's the difference between your BioSentinel experiment and the one that's going to land on the moon.
So the BioSentinel experiment is only sending 2 yeast genotypes, a wild type and then a RAD51 mutant. And they have basically every single microfluidic device has just those two genotypes, and then they're going to activate them over a long period of time as the satellite's in heliocentric orbit. So it's really in deep space, right, and not on the surface of the moon.
So the BioSentinel will get a longer time frame than the PRISM mission will.
Exactly, and also it's not testing anything to do with bioproduction of the carotenoids. So we're going to get a little bit more information about how metabolism is affected by radiation in the in the Leia mission.
Got it. Thanks.
Yeah.
Real quick, I'm going to ask one for Carrie that's online. So great talk, Carrie. You mentioned possibly being able to detect hydrogen. What threshold abundance would you need to be able to do that? And this is from Jess Barnes.
Yeah, so that's probably a really good question for Tom Prettyman to do those back of the envelope calculations. I know that in, I think it was Shuai Li's work, he was looking at, or they had identified on the order of hundreds of ppm in the red spots, or particularly at the Gruithuisen domes. And I think at that level, Tom had indicated we would not be able to detect that hydrogen. So it would have to be at higher abundances than what's currently estimated from remote sensing data.
Chip Shearer from the University of New Mexico and the Lunar and Planetary Institute. Carrie, congratulations, terrific talk, great mission. It's nice to see that you're going to be able to determine porosity, because that's really important in understanding degassing and eruptions, but also what's critical based on analyses and observations at terrestrial domes is the size and distribution of vesicles. What sort of capabilities do you have on the cameras that allow you to potentially look at these features?
Yeah, so on the rover, the multispectral camera will have spatial resolutions that I think they're on the order of 0.08 centimeters.
Oh, great.
When we're standing off of that rock from 3.6 meters. And so, you know, if the vesicles are around the order of a centimeter or half a centimeter, we should be able to identify them in our visible images.
Okay, great, thanks.
Great. Do we have any more questions for Mark or Carrie? I don't see any more online. So again, thank you and congratulations, Carrie and Mark. And for others who hope to one day stand in their shoes, PRISM 3 will be out hopefully by the end of the summer. So stay tuned.